Question number 12. So let's see. So in this question, we're going to use Newton's method to find a solution for this. So with Newton's method, one of the things that we want to make sure we're doing is we want to make sure we have a function, right? So cosine of x equals 2x is actually two functions together. What we could do is we can say, well, let's let f of x equal cosine of x minus 2x, right? If I brought the 2x over to the other side, because now solving this question, cosine of x equals 2x, is the same as saying, hey, where is f of x equal to 0? What is the root of our function? All right, so to use Newton's method, that was a weird way for me to talk. We would have to take a derivative. Derivative of cosine is negative sine of x minus 2. All right, so then we want to find some solutions for this, right? So we want to find a 3 decimal point accuracy. So in this case, I would probably use something like, I don't know, probably 0 as my initial guess, right? Because I know it's the cosine of 0 is 1, 1 minus 2 times 0 is 0. So I get a 1 out of here. So I'm not going to go crazy with this thing. I'm going to use technology because, like, hey, it's, 2022. Depending, I don't know when you're watching this, I might use this for like years. All right, so we would have cosine of x, and we're taking away 2x. Right, so then we can see that our root is somewhere between 0 and 1, right? So we can kind of see exactly where it is right there. So I'm going to guess maybe my initial guess, which I said was 0. Right, so if I use 0 as my initial guess, I get 0.5 as my next guess. If I do 0.5 as my next guess, this gives me 0.45062669. So we got 0.45062669. Was that what it was? 450626669. Did I get that? Hey, good job, memory. So then if I plug in 0.45062669, I'm going to then get 0.4501. Get 0.4501, 8355, something like that. 0.8365. I was just talking about how good my memory was, and then that happened. And then if I plugged in that value, I would get 0.45018361. So we'd get 0.45018361, right? So we can kind of see that we're converging to 4.5 and some change. All right, so 0.45018361. Where's that pulling right thing? This was 0.5. 0.45018365. That can be 0.45018361. And you can see that we have a lot of accuracy between these last two answers, right? 4501836, right? So we agree all the way up to what this tens, hundreds, thousands, 10, 100, millionth, 10 millionth place. So that's a lot of accuracy. So our solution here should be like 0.45018361-ish. And what does it says just 0.45, right? So again, kind of lazy. We're better than Desmos. So to 3 decimals, we did such much more than that. All right, so our solution would be 0.4501836. Right, so technically 0.450 because I said to 3 decimal point accuracy. But that is your answer.